Section 4.5, Scatter Plots and Correlation. Essential question. How do you determine if there's a correlation between two variables? There are 4 vocab words in this lesson. The first vocab word is positive correlation. So let's first of all look at the graphs that we have on the right here. These are called scatter plots. Scatter plots are just a bunch of data points that are graphed on a coordinate grid. The lines are not, the dots are not necessarily connected, and then they're all spread out all over the graph. A positive correlation means that the dots are going up from left to right. So you'll notice in that first graph, all of our blue dots are going up from the left, bottom left corner to the upper right corner. The second type of correlation is a negative correlation. You'll notice the blue dots in this graph are going down from the left to the right. So in the upper left-hand corner of our graph to the bottom right corner of our graph, they're going down. No correlation means that the dots are all scattered throughout and there is no trend. They're not going up from left to right or down from left to right. They're all over the place. A line of best fit is a line that is drawn to show the trend of the data. The trend of the data means which direction is the data going. So if we draw a line of best fit for the top one, the positive correlation, I want a line that's going through the middle of the blue dots. The line is not going to connect all the blue dots. It may pass through some of them, but most of them it will not. So if you draw a line of best fit through the positive correlation graph, it should look something like this. It went through a few of the dots, but not all of them. A line going up from left to right is positive correlation and is similar to positive slope. Our negative correlation is going down from left to right. So I put a line going down. It goes through a few of the dots, but not all of them. If there is no correlation in a graph, we don't want to draw a line because it means that there is no real relationship between the two variables. Which of these shows the best line of fit for the scatter plot? So we need to look at A, B, C, and D to figure out which one has a line that goes through the data points and gives us a good idea of how the data is trending. If you look at letter A, our line is going down from left to right. It goes through one of the points, but a lot of the other ones are far away from the line. If I were to draw a line of best fit for this one, I think I'd be going up from left to right rather than down. If you look at letter B, our line of best fit is going through 2 of the dots. 2 of them are close, and then 1 is far away. That one looks pretty good so far, but let's look at C and D before we make our final choice. C, we've got a horizontal line going through only 1 of our dots. There's a bunch of other ones below the line. If I were going to draw a better line of fit for this one, I think my line would go something like that. If you look at letter D, they're doing what you're not supposed to for a scatter plot, and that's connecting all the dots except for that one at 1050. You don't want to connect all the dots in a scatter plot. You want to show a trend line. It needs to be a straight line. That one is not straight. So I think that letter B would be the best choice. Determine if this graph shows correlation. If it does, draw a line of best fit and describe the meaning of the situation. I think that this graph does show correlation because you can see all of the blue dots are going in a similar direction. They are all going down from left to right. So there might be a good line of best fit. We also need to describe the meaning of the situation. So let's look at the title and our axis labels. The title of this graph is Computer Sharing in Maria's School. The x-axis is the year, the y-axis is the students per computer. So you'll notice that as the year goes on, 2000, 2004, 2008, the number of students having to share a computer is fewer. If you take this coordinate point that would be about 2,000, comma, maybe 37. So that means in the year 2000, 37 students were using the same computer. If you pick a dot at the other end of our graph, maybe this one, that would be 2009 and about 9. So that means in the year 2009, only 9 students were sharing a computer. So we will say, as time passes, fewer students are sharing a computer. So I'm going to assume that that means that this school is getting more computers as the years go on, as we use technology more and more in school, and then less students have to share those computers because there's more of them. All right, same thing. We're going to determine if this graph shows correlation. If it does, we're going to draw a line of best fit, and we're going to describe the situation. So if you look at these dots, it's actually a very straight line. We're going to end up being able to connect most of those dots for our line of fit. If it's going up from left to right, this means that there is a positive correlation. If you go back to our last one, it was a negative correlation. So I might add on that, because yes, it said determine if this graph shows correlation, so we should say yes, it is negative. So this one is going to be yes, there is positive correlation. And now let's figure out what the meaning of this situation is. The title of this coordinate grid is mail order prescriptions. So that means how many people are getting prescriptions through the mail. The years start out from 1995 and go all the way to 2000. And then on the y-axis is the number of prescriptions that people ordered. Let's take 2 of our coordinate points at both ends of our graph. So right here, I have the coordinate point 1995. Oops, I had an extra comma in there. And we'll say about 88 million. So in 1995, 88 million people were ordering prescriptions. And in 2000, 145 million people were ordering prescriptions. So that means that as time goes by, if you look at 88 all the way to 145, more people are ordering prescriptions by mail. So it's becoming more popular for people to order their prescriptions through the mail rather than going to the drugstore or the pharmacy to pick them up themselves. Determine if this graph shows correlation. So let's do that first. It looks like my dots are going up from left to right, so that would be positive correlation. We drew our line of best fit, so let's describe the situation. This graph is called calories burned during our exercise. So on our x-axis, we have the amount of minutes people worked out, and on the y-axis, we have the number of calories people burned. Let's take 2 random coordinate points. So we'll pick this one on the bottom left, which would be about 4 and 20. And let's pick this one up here, which would be about 48 and 410. So the first one, 420, means after 4 minutes they burned 20 calories, And the second one means after 48 minutes, they burned 410 calories. So what we would want to say to describe this is the more time spent working out the more calories burned. Which, if you think about that, that would make sense. The longer you work out, the more calories you're going to burn. All right, let's look at the correlation for this graph. It looks like the dots are going down from left to right, so that means it's a negative correlation. I drew my line of best fit, so now I need to describe the meaning. The title of this graph is weightlifting. The x-axis is the weight in pounds. The y-axis is the number of repetitions. So how many times you do that exercise. So pretend you're standing there with dumbbells, little hand weights. Maybe you have 5-pound dumbbells. How many times do you lift those dumbbells? That's repetitions. So let's pick 2 random coordinate points. Maybe I'll pick this one on the left, which would be 2014. So that means for 20 pounds, they did 14 repetitions. And if I pick one down here, I'll go with this one. So for 120 pounds, they did 2 repetitions. So if you think about what that means, when the weight of when they're lifting is higher, so 20, they did a lot, or was lower, they did a lot more repetitions. When the weight was higher, 120, they did only 2 repetitions. So we'll say the higher the weight, the fewer repetitions. So the more weight that they're weightlifting, the fewer they can do, which makes sense. If you have a light weight, you can lift it a lot of times. If you have a heavier weight, you can't lift it as many times because it's harder. All right, determine if this graph shows correlation. So this graph has dots all over the place. I don't see any trend going from the left to right up or left to right down. So this one has no correlation. If there's no correlation, we don't draw a line of fit because there is no relationship between the 2 variables. Let's look at this graph a little bit more to understand its meaning. The title is library fines, and then the x-axis is books borrowed, the fine is in dollars. So what this graph is saying is there's no real relationship between the number of books you borrow and the number of fines you end up with. Some people may borrow a ton of books and always return them on time and never get fined. Some people may only borrow a few books but never return them on time and always get a lot of fines. So there isn't a relationship between how many books you check out from the library and how many fines you get. Some people are good about returning their books on time, some people aren't. All right, this one, I see some correlation there. It looks like it's going up from left to right, so that would be positive. We drew our line of best fit, so let's describe the meaning. The title of this one is Car Dealership Revenue, so how much money a car dealership is making. We've got the years from 99 to 2008, and our revenue, or how much money they made, in hundreds of thousands. So let's pick 2 coordinate points. So in 99, their revenue was about 300,000, and in 2007, their revenue was about 800,000. So that means that as years go as the year goes by, they went from 300,000 to 800,000, so their revenue is increasing. So we'll say as time passes, the car dealership revenue is increasing. Summary. The homework for this lesson is getting started on your scatter plot packet.